All right, so we're talking about compound interest. Let's see, where is it? All right, compound interest. So a little real-world application. How about that? Not every day we get that. So I want to start with a simple version of this. First of all, does everyone know what interest is?
Yes.
Economics.
Yeah, economics. Okay, so interest is basically, here's what it is. If you have a savings account in the bank and you put like $100 in there, basically interest is money that the bank gives you for letting them hold on to your money. Because what they're able to do with that $100 is they're able to lend it out to people when people need loans and stuff like that. And so they're paying you so that they can have your money to lend out to people. And the reverse is also true. When you have like credit card loan or a student loan, something like that, which will be really relevant for you guys very soon, if it's not already. But basically, you're borrowing money and you're keeping that money, and so the interest is a little bit of money that you pay to keep a hold of that money. So whoever is keeping the money gets to make a little bit. So a savings account has a pretty low interest rate. It might be like 1.5%, or even lower than that per year. And so like after a year in your bank account, there would be $101.50. And it's not very much, but also it's better than $100 just sitting there. And of course, the more money that you have, the interest percentage is the same, but the more interest you make. So yeah, that's what interest is. And then here's what compound interest is. We'll start with a simple example before we get into the weeds here. So let's say that we put $100 into an account. Hey, you guys. Dude. Let's say you take $100 and put it into an account, and let's say that this account, this is very unrealistic, but let's say that you get 100% interest per year. And so I put $100 in, and let's say that we only calculate that interest one time per year. At the end of 1 year, how much money will you have in your bank account? $200. Because you are getting 100% of your money, which is $100, added to your money. So you'll have $200 at the end of the year. Now, this is where we get into compound interest. Sometimes, frequently, we will calculate interest multiple times a year. So let's say we're calculating it 2 times per year. That doesn't mean that you get 100% both times. What would you get both times? 50%, right? Instead of getting 100% once, you're going to get 50% twice, adds to 100. So the first time they calculate interest, so let's say you deposit your money January 1st. July 1st, you're going to get 50% interest. So on July 1st, how much money do you have in your bank account? $150. Because 50% of your money is $50, and then we're adding that to the total. Then December 31st comes around. We're going to get 50% interest again. What is 50% of 150? 75. So you're going to get $75 this time. So how much are we going to end up with at the end of the year? $225. Okay, so notice even though we're getting the same interest rates, when I calculate it twice, you actually end up with more money. So the more times you calculate, the better. Let's say that we're going to do this 3 times a year. What do we think? Are we going to end up with more money this time? Yeah. This one might need a little bit of a calculator assist, but a third of the way through the year, how much money will you get as interest? $33.33, right? So it's going to be a third of 100. So 133.33, that's what we have. Then the next time we calculate it, we're going to get a third of that. So this is why it's growing, is because the amount that we have in there is growing. So that's going to bring me, I'm getting now $44.44. That's taking me to 177.88. So what I did was I did this number here divided by 3, and then I added the result to 133. So then this number, to calculate the next one, I would take this one and divide it by 3. So divided by 3. So that's $59.29. And then I'm going to add it to that number. Yes. So now how much money do we end up with? $237.17. Okay, I want you guys to calculate that for when we do it 4 times. You can take 100, divide it by 4, add it to 100. Take that number, divide it by 4, add it to the previous result. Take that number, divide it by 4, add it to the previous result. Take that number, divide it by 4, add it to the previous result. Where's that go? Okay, how much money do we end up with? $244.14. Here's another way that you could do this. You guys can try this right now. So on your calculator, type in 100 and then hit enter. Okay, everybody do that? Type in 100 and then hit enter. Then hit times. So notice it now says answer times. And what am I going to multiply by? 1.25. Hit enter 4 times. Yeah. So basically multiplying something by 1.25 is like the 1 keeps it the same, the 0.25 makes it grow by 25%. So it's a little faster way to do that. Okay, notice how there was kind of a big difference between $200, like calculating it once a year and then calculating it twice a year. There's like $25 difference. But going from 2 to 3 was less than that, right? It was not a $25 difference, only like a $12 difference. And then here it's even less. It's like a $7 difference. So the more times you compound it, it's not growing at the same rate. It's really what it is diminishing returns, and that's like actually what it's talking about. So it is better the more times you compound it, but only to a certain point. It's not like, oh, if I calculate it 10 times a year, I'm suddenly going to have $1 million in here. It's not really how it works. But basically, the more times we calculate it, the better. Okay, so even as easy as that last little trick was with the calculator, it does get kind of complicated when you're dealing with not $100. $100 is a very easy number to work with. Not 100% interest, that's also a very easy number to work with compared to some of these others. So we have a formula that helps us calculate these. And here it is, right here. It's A equals P times that thingy to that thingy. So A stands for amount. And what that means is the final amount. P is the principal amount, which means starting amount. R is the rate, which is a percentage as a decimal. Oh boy. Sorry, it's hard to write on this. So like, for example, what is 50% as a decimal? 0.5. Yeah. So it's going to be as a decimal. T is going to be time. And we're normally going to put that in years. And then N is the number of times interest is calculated per year. And frequently, instead of saying calculated, we're going to use another word that also means calculated. That word is compounded. In this sense, it means calculated. So we see compounded just means calculated, which is what we're doing up there. Okay. So really it's just using this formula, learning how to solve for different things. It's not too bad. So if it says find the amounts in the account, what am I solving for? A. It can be A equals. Okay, the principal is $100, so that means I'm going to make P 100. And then it's 1 plus, okay, compounded quarterly for 3 years at 6% interest. So what is R going to equal? 0.06 over, what's N going to be? 4. Quarterly means 4 times a year. Okay. I wrote N, I didn't write 4. And to the power of what? Yeah, it's going to be to the 12th power because it's 4 times 3. Okay. So that can just go into the calculator. And here's how you should do it. Everyone look here for a second because this is where it always goes wrong. Okay? These calculators are amazing because they let you type in everything all at once. So instead of doing like this, then +1, then to the 12th power, and breaking it up into a million little steps, type it in all on one line on the calculator. So you should literally be typing, where is it? 100 parentheses 1 plus, and it's going to look like this, 0.06 divided by 4, do the little caret to the 12th power. This is what you should type in. So go ahead and type that in. Let's make sure we get the same thing. Okay, make sure your answer matches mine. If it doesn't, raise your hand. Okay, did everybody get that? So we get $119.56. All right. Okay. Example number 2, it says how long. So what are we solving for? Years. Yeah, we're going to be solving for t. How long would it take for $2,000 to double if the 5% interest is compounded semi-annually? So what's our final amount here? 4,000. 4,000 equals 2,000 parentheses 1 plus, what's going to go on top? 0.05 over 2. Semi-annual is 2 times a year. And then to what power? 2t. Okay, so we're solving for t. T is a variable, it's an exponent. We're going to have to figure out how to get it by itself. So first thing we want to do, anyone know? Yes, divide both sides by 2,000. We got to get that parentheses by itself. It's very, very similar to that last example we were doing on that classwork. So we have 2 to this. Okay. Now we could evaluate this number inside the parentheses, but also I prefer to just leave it and type everything in all at once so that the calculator does that, and then I can see all of the steps of my equation. What?
Would it be like if we did 4,000 divided by 2? Would it be 2,000? Would it be 75 to 2?
Yeah, 4,000 divided by 2,000 is 2. Yeah, you good. Okay, so we want to get t by itself. T is an exponent. How do we get variables by themselves when they are exponents? What do we do? Huh? What do we use? What's the opposite of an exponent? Not square root. Logarithms. Logarithms. Okay. So this is very, very similar to a problem that would be like, 2 equals 3 to the x plus 1, something like that. Where we have x as an exponent, we would take a logarithm of both sides, in this case probably log 3. For these problems here, just to keep everything the same, just to keep our problem solving process the same, instead of using log 2, or instead of using log of this crazy thing right there, we're just going to take the natural log of both sides. And that might not make that much sense for this example, but it's going to be really nice for the other examples. My handwriting is struggling today. Okay, the reason we use logs is because what can I do now? Yeah, we can put the 2t in front. Okay, so this is 2 times t times natural log of that stuff in the parentheses there. I want to get t by itself. T is being multiplied by how many things? 2 things. What's the opposite of multiplying? Dividing. I need to divide by how many things? 2 things. I need to cancel out both of those things that t is being multiplied by. So that's 2 times natural log of 1 plus 105 over 2. I'm just dividing by everything except t. If I don't have a calculator, this would be my answer. Natural log of 2 divided by 2 natural log 1 plus 0.05 divided by 2. All right, let's make sure we know how to enter this into the calculator. If you have, raise your hand if you have a TI-84. Nice. Press alpha, and then y equals, and then press enter. This is for 84s only. 83 won't work, sorry. Okay, do you see what that did? It gave you this little box where you can type a fraction in. So TI-84 people, you're going to just write natural log of 2 over 2 natural log 1 plus 0.05 over 2 like that. Did everyone get that to work? That fraction thingy? 84 people? Kind of. What do you mean kind of? Yeah, 83 is we just gotta. Yeah, percentage. Yeah, so percent. Oh, yeah. How do I write this? All right, T83s, we're doing it old school. We got to use parentheses. So it's going to be natural log of 2. You see, everyone see where natural log is, by the way? It's on the left side, ln. Yeah. Natural log of 2, close parentheses, divided by, check it, these parentheses, everyone forgets them, these red ones here. Don't forget them. We're going to need 2 natural log parentheses 1 plus 0.05 divided by 2, close parentheses, close parentheses. We need, you guys with TI-83s, you need these red parentheses right here, and you also need to make sure that you close that one. Make sure we get all those parentheses in there. Those are the hardest ones to remember, but if you don't type them, your answer will be wrong. Yeah, and make sure your answer matches mine. If your answer doesn't match mine, raise your hands. Yeah, I didn't say it was around, but alpha y equals. Yeah, that's good to review.
Are we going to get calculators on the formative?
This part of the formative, yes. It'll say, like in the assessment, say what you're talking about. For money, always do decimals.
What's your gas
What?
The alpha y equals
Alpha.
What's your gas station?
Alpha.
They go like
Y.
$3 or like $2.70 plus like 9%.
You've got an old 84.
It's like two.
Yeah.
Two.
I mean, you can get the software updated and all. Which is weird because you have a button for it. You have to add one button. That's very strange. Well, you just have to do it that way.
Okay.
Everybody get that? It's not fun. Okay, so we get 14 point something 036 if you round it to 3 decimals. On the formative, on the summative, whatever, it'll always tell you how many decimals to round to, so just make sure you read the directions. It's probably going to be 3 decimals. I just like 3 decimals. Unless it's money. Money, we always go to how many? 2. Always 2.
How's your guess?
Unless you're a gas station. Great joke. Love that. That's good.
Yeah.
Okay, and what are the units for this? Years. So make sure we include units. Okay, that's a lot of time, but we're asking for our money to double, right? It takes a long time for your money to double if you put it just into an account where it's not doing anything. All right. So, I gotta erase all this here. Now we're talking about continuous interest. So continuous interest is not really a thing that exists in real life, but this is more for like, if you look on the back of the notes, if we talk about exponential growth of like a bacteria or something like that, or like half-life of a chemical, which you're talking about in chemistry class, maybe even right now. Who's taking AP chemistry? Anyone? No? Okay. Well, maybe that's why you guys are all in this class, because no one's taking AP chemistry. As opposed to like the people in my 7th period might be in it because that's how their schedule works out. That's usually how it goes. But anyways, half-life would be like you have some kind of radioactive chemical and half of it degrades every so many years, and you can calculate how long it's going to take. That's how they do like carbon dating, figuring out how old stuff is. So it doesn't really have with interest, but bacteria, it's not like the bacteria is going to multiply 4 times a year. You know, it's like always multiplying. But we're going to do it with interest just to model it. So what that would mean is, instead of having your interest calculated like 4 times a year, it would do it an infinite number of times per year. Which again is impossible to do. You can't really do this, but other real world situations will follow this. So if it's an infinite number of times per year, and let's say it was 100% interest, an infinite number of times per year, how much would you be getting each time it was calculated?
Double every single.
It's not going to double every single time, because remember, if it's 2 times a year, you get 50% and 50%. 3 times a year, you'd get 33, 33, 33.
Right.
So if it's infinite number of times a year, how much are you getting each time? Yeah, it'd be like 100 divided by infinity. Exactly. So it's like, which is pretty much 0. But you would be getting, you know, if you think about it, you would be getting something. It would just be a very, very small amount. But you're getting it all the time. And so it's kind of weird to think about this, but basically, if you think about that, oh my gosh, what is this? That formula up there that says 1 plus, the rate would be 1, that's for 100%, divided by infinity to the power of what? I'm using this formula right there. Yeah, to the power of infinity. And if we just do it for 1 year, and you start with $100, here's what the amount would equal. Your calculator can't do it, but I know what it is. It's $271.83. That's how much money you would get. Yes. At the end of 1 year, if you had 100% interest compounded continuously. Because this number right here, this is the number E, which is 2.7183. So there's 100 times that number right there. So this is where the number E comes from. This is what it represents. It represents continuous 100% growth. It represents how much you would have if something was doubling over the course of a period of time, but continuously like calculating that. And so this is like the most money that you could get is $271 because it's E times. So we use this number E to represent continuous interest. Now this is a little hard to think about. It's a little abstract. It's a little out there, a little wacky. In terms of calculating this, the problems are pretty easy. So here comes the easy part. I'm going to do the hard part first. A is the amount. P is the principal. R is the rate. T, the time. And E is roughly 2.718. Do not use this number to calculate it. You should use the button on your calculator that has the E on it. E is in two places. If you press second and then the division sign, that's E right there. If you press second and then natural log, it will automatically give you E to a power. Yes, that's what we're going to use. We're not going to use the rounded version, we're going to use that version. Okay, so example 1, find the amount in the accounts. What are we solving for? A equals what? 100 times E to the points 18, yeah, so it's like 3 times 0.06, yes. In the calculator, the way that I would type that, it's going to look like this. I just like to have the calculator do all that. So make sure that you get the same thing as me. Raise your hand if you don't get this number right here.
No, it's not 340. I was asking.
I don't know. I think this is Are you gonna remember it? Are you gonna remember something?
I see.
Yeah.
How did we go from like it's just
Oh. I didn't
how did we
know
go
that.
from 0 like it's 100 E
I think it's
to
actually-
8? So how did we
That's not an A, that's the actual.
oh right, but like is it the 120? So if I wanted to do it like if I did 100 E, right? And then did 8. Oh, I did 7. Okay.
Yeah. Yeah. I like to keep it in parentheses there just in case I multiply wrong.
Okay.
I don't always trust my mental math. Okay, so compare this example to the first example 1. Notice that the parameters are basically the same. What's the difference? Difference is about what, like 12 cents, 14 cents? All right, see what I'm talking about? Yes? No? Hello?
Yeah.
Yeah, okay. Oh, I had to erase it already. But yeah, so we get basically the same amount. We just get a little bit more. Again, we're talking like 6% interest. Not going to be very much of a difference, but it is a difference. Okay, example 2. How long would it take? What are we solving for? Solving for time. For $2,000 to double if 5% interest is compounded continuously. So again, very similar to example 2 from before. So 4,000 equals 2,000 e to the 0.05 t. What would our first step be? Okay, so notice that once I divide by 2,000, this leftover equation here is the same thing as asking how long would it take for $1 to double under these circumstances, right? It's like I'm going from 1 to 2. So whether I'm going from 2,000 to 4,000, it's going to take the same amount of time to double as if I'm going from 1 to $2 or 1 million to 2 million. So what we can do is we can actually skip this first step if we wanted. So what if it's at triple? How would I change this equation I just got? Instead of writing 6,000, I would skip that step. I could just write 3 equals, right? So if we start to get used to that, we can skip a little step there, make it a little bit easier on ourselves. Okay, so t is an exponent. What am I going to do? Natural log both sides. I'm going to have natural log of 2 equals, this is starting to look familiar, right? Hopefully. What happens on the right side? Yeah, it's going to cancel out. Okay, my last step here would be divide by 0.05. Okay, again, if we don't have a calculator, that would be my answer. If we do have a calculator, so go ahead and type that in, make sure you get the same answer. Okay, we'll get that results.
Do you not see?
Okay. I want you guys to do example 3. All right, guys. Let's check this one. Okay, so we set it up here. We have 1,200 equals 300 times e to the 4 times r. First step, divide by 300. So 4 equals e to the 4r. Then natural log both sides. So we get natural log of 4 equals. Yeah, it just equals 4r. And then last step, we're getting natural log of 4 divided by 4. Okay, again, if we don't have a calculator, that would be our final answer. A quick word about what the actual final answer is. So r, we would say equals 0.34, depending on how you round it, 347. The best way to give this answer though would be to give our answer as a percentage. So that result I would multiply by 100 to convert it into a percent. So I would say, depending on what I'm told to round to, but I like 3 decimals, so I usually do that. 34.657%. Questions on that process? Yeah, and again, formative, some of them are going to say what to round to. So. The directions will be clear on the formative to say round to give as a percent. Yeah, I typed them myself. Okay, that's actually it. We're not going to go into the part on the back there. We're just going to do the front. So we you guys can go work homework.
Yay.
Yeah.
You might do your one.